Hi and welcome back to my channel, and today we're going to be looking at loci. Loci is a topic that appears in further maths complex numbers, so this should be a bit of a revision. I realise that to my main audience currently, this is after the further maths exam, but so what? So the first loci we have is a circle. And this will be denoted as the mod of z minus w is equal to r. So what this is saying is a circle, centre w, or rather z is the set of points where the distance between z and w is uniform all the way around, is equal to this radius here. So therefore, w is a plus bi, but w is our centre. So this is a circle on our Argand diagram, so with a real axis and an imaginary axis. Let's say w is here, and r is about this much. Our circle's going to look something like this. Obviously, you can have less than or equal to, less than, greater than, all the inequalities if you wanted to. Next, we're going to be looking at the half line. And this is denoted as the argument of z minus w, so argument, which is basically the angle. The argument of z minus w is equal to theta. So what this would be is a argument centre z at an angle of theta to the positive real axis. So here, that's to the real axis, and this angle here is theta. And we draw it with an arrow. That's just how you draw a half line. Finally, you have the perpendicular bisector. Perpendicular bisector. This is probably the least common in further maths, but it's still one you need to know. And this is z minus w, or rather z minus w1. It should be mods around that, so straight lines. Z minus w1 is equal to z minus w2, and it's also the mod value. And what this will mean is that you have 2 points, w1 and w2, and there will be a perpendicular bisector between them. So the distance from this set of points is the same no matter which way you do it. So if you say we're going to the point here from this one here, your w2, so here is w1, your w2 has to go the same distance. That's why it's the perpendicular bisector. Okay, so let's do, we're going to do one example. And because I like circles and half lines, we're going to use those. So, real axis and an imaginary axis. So, we have to shade the region enclosed by these two sets of loci. So, mod z plus w plus I is equal to 3. And shade the region enclosed by that, and the argument of, let's do 1 plus 2i, so sorry, z plus 2i is equal to pi by 4. I'm choosing pi by 4 because it's a nice angle, and it makes my example easier. So the first thing is we know it's in the form z minus w. So I'm going to rearrange that to do z minus 1 minus I, because that's what it actually is equal to 3. So it's a circle, centre minus 1 minus I, and radius 3. So we're going to draw that. So minus 1 is here, minus I is here, so centre here, and this circle will do roughly this. Not very well drawn circle, but you get the idea. And then we have our other complex number here. So z, that will be actually the arg of z minus 2i. That is very important, is equal to pi by 4. So this will be a half line minus 2i and pi by 4. So this will be below this point here, but also above where the circle intersects, because the circle has a radius of 3. So around here, and we're going to draw our line to the normal, the positive real axis, and then we are going to draw our line. So out at 45 degrees. So our region enclosed is, I'll put it in colour. Our region enclosed is this region here. And thank you very much for attending this video, and I will see you all next time. Just trying to stop the video.